Hello, I am Himanshu. Welcome to our project or tutorial building weather monitoring system using NodeMCU, Anedya IoT Cloud and Streamlit. In this video, we will walk you through each component and the challenges we faced and how we solved them. Our, our weather monitoring system integrates various sensors to measure parameters such as temperature, humidity, UV index, atmospheric pressure, soil moisture levels. Let's dive into each component and see how they work together. Let's start by introduction. The main components of our project. The DHT22 sensor. It is used for measuring temperature and humidity. It's provide accurate and reliable reading, which are crucial for environmental monitoring. These sensors contain a capacitive humidity sensor and thermistor to measure the surrounding air. It also an integrated chip to convert the analog signal into a digital signal that microprocessor can read. Next, we have GUVA S12SD UV sensor, which is measure the ultraviolet index. This sensor helps in monitoring the UV radiation levels, which can be critical for various applications such as agriculture and health. The sensor used a photodiode to detect UV lights and proceeds a current proportional to the UV intensity. This current is then converted to a voltage then the microcontroller can be read. Next, BMP 180 sensor is used for measuring atmospheric pressure. It is high accurate and can also be used for calculating altitude. The BMP 180 sensors consists of a piezo resistive pressure sensor and an integrated temperature sensor. The pressure sensor measures the absolute pressure of the air while the temperature sensors for any temp variation. Next, the soil moisture sensor measure the volumetric water content in the soil. The particularly useful for agriculture application helping the optimize irrigation system. The sensor uses two probes to probe to measure the resistance of soil. When the soil is wet, it conduct electricity better, resulting in lower resistance. Conversely, dry soil has higher resistance. Then, the heart of our system is the ESP8266 microcontroller. It is a low cost, low power microcontroller with built-in Wi-Fi, making it ideal for IoT application. The ESP8266 has several GPIO pin for connecting sensors. It also supports various communication protocol, taking it very style for different type of project. We overcome the limitation of having only one analog input pin on the ESP8266. We uses we uses CD4051 IC. They allow use to connect multiple analog sensors to single analog pin. This CD4051 IC MUX has 8 input channel and one output channel. By selecting the input channel, we can read data from multiple sensors using a single analog input pin. Finally, we use a 0.96-inch OLED display to show the real-time data. This is compact and provide high contrast, making it easy to read even in bright light condition. Now that we are introduced the components, let's move on the building the system. First, we connected to the sensor ESP8266. Here we connected DHT22 sensor to pin number B3 for temperature and humidity reading. The UV index sensor connected with channel number 0 to CD451 IC and soil moisture sensor connected with channel number 1. BMP180 sensor connected with I2C protocol to ESP8266 and 0.96 OLED display are also connected to I2C protocol to ESP8266. Once everything is connected, the ESP8266 microcontroller read the data from the sensors and display it on the screen. You can see temperature, humidity, UV index, pressure and soil moisture level. When we initialize setup the system, we faced problem with the time synchronization. The data timestamps did not match the real-time sensor reading. To debug this, we added several print statement in our code. To log the time data we send to received by the server, this helps us to identification by the lag and incorrect timestamps. Now we faced a challenge with the analog input. The NodeMCU has only one analog input pin A0, but we need the read multiple analog sensors. Example, UV index and soil moisture are analog outputs. We solve this issue using CD4051 IC. The multiplexer selects which sensor data reads at given time, effectively expanding the number of analog inputs. Next. In Anedya IoT Cloud play a crucial role in our storing and monitoring the sensor data. It's provide a robust platform for IoT data management and real-time data access. The node MCU sends the collecting data from the sensors to Anedya IoT Cloud via Wi-Fi. The cloud platform stores the data which can be accessed remotely by for analysis and monitoring. In dashboard section, to visualize the data, we use Streamlit, an open source framework that allows us to create interactive web application easily. Streams easy because it's simpler the process of creating a real-time dashboard to monitor the environmental conditions. The Streamlit app fetches data from Anedya server and display on it in real time. You can see temperature, humidity, UV index, soil moisture, and pressure. It is refreshed and updated in every minutes. By combining NodeMCU, Anedya IoT Cloud, and Streamlit, we will build a comprehensive weather monitoring system. These projects highlight the power of IoT. We hope this tutorial has been informative and inspire you to create your own IoT project. Thank you for watching.